Bismillahirrahmanirrahim. Dear students, the last two questions of sheet 9 we will be doing it now. Okay, so it's about the program, means we need to write the binary assembly language program, okay, with the binary equivalent instructions here. So what we have, he said that list assembly language program generated by a compiler for the following program here, Fortran program. Assume integer variables here. So what he said that we are given a piece of a program which is equal to sum equal to 0, sum equal to sum plus a plus b and so on. So this is a piece of program from a Fortran language here. So what we are interested in writing the equivalent assembly language program here. Now, what I will do, I will assume each instruction or each statement in the Fortran language individually here, okay? Because it's not a complete program, so you don't know exactly what are the values or what is of the some A, B, C difference, like all these variables here. Although he is saying that these are the integer variables here. Okay, so but just understanding it because we will be using the same concept in our last question here. So first of all, what he said that we are given a sum here, sum equal to, you can say like I said, two brackets here, which mean empty, or maybe like sometime in the, maybe you find it like this, okay, because I have not done the assembly language throughout in my life here, okay, so I don't know what is the syntax here. The meaning is either it will be 0 or sum equal to like the two brackets here. The meaning is my variable sum is basically equal to 0 or it's empty here. So what we are doing here basically, to write the equivalent program here, assembly language program, what we will be doing here, we can take an accumulator and we can clear this accumulator. So if you clear the accumulator, it means that the value in the accumulator is 0 or this is empty, you can say in other words. So we can store that accumulator in certain variable in a memory. We call it as a sum here, or we can tag it as sum here. So let's suppose we say that for sum equal to 0 or sum empty, we say that, let's suppose first of all we clear accumulator. This is now the with the blue I'm writing it in the equivalent assembly language program here. So it means that CLA means clear accumulator here. Okay, then what you can do, you can say that store accumulator. So it means I'm going to store the value of accumulator in sum here. So basically in a memory you can, so I have certain address sum and I have stored this value of accumulator in the sum here. So it means that my sum has the value of 0 because my accumulator is empty here. Okay, simple. Second one is basically sum equal to sum plus a plus b here. So it means that in the second one I'm saying that we have three variables here. So I mean you can start from any variable, doesn't matter. So what we will do, we said that in the memory we have three location or three variables stored in the memory, which is like sum a and b here. We don't care about the value, but according to the question these are some integer values here. So what we can do, we can load one of the variable, then we will add that variable with the second variable, and then we are going to add the result of this one in the third variable here, and then we store it in the sum here. Okay, so it doesn't matter which one you load first. Okay, so up to you. So what I will do here, let's suppose I say that first of all i'm just loading LDA load load accumulator. Okay, so LDA means load accumulator. I am loading sum here right now. So I have loaded the variable sum in accumulator here. Let's assume the value of sum is 5. So in accumulator the value will become 5 here. After that we say that add A here. You can do B here, it doesn't matter, okay, which the order is not important. The important thing is we need to add all three of them and store it in sum here. So add B here. So if you remember, for addition normally we said that this was accumulator plus some data register here. This data register value is coming from the memory here, okay, like for example here the value is coming from A or something. In accumulator already I have sum here. So when you add them, so it means my accumulator value will be equal to sum plus A here. Okay. Similarly, I need to add B also here. So I will again say add. Okay. Just it's in the same sequence. Okay. There is no space in between here. So we can say add add B here. Now what happened? I have added a sum with A, then added the sum plus A with B here. So it means I have total completely added sum plus A plus B. Now what we need to do here, we need to store the value of accumulator. So what I will do, I will say store accumulator in sum here. Okay, again I route it here, it should not be, it should be in the same line here. Okay, so you can say store accumulator in certain variable sum here. So basically, I loaded sum, I add A, then I add B, and then I store the results of accumulator in some variable again. Simple. Okay. The next one is basically DIF is equal to DIF minus C here. So basically what I am doing here, I am loading certain variable DIF and I am subtracting from that DIF value the value of C here, okay, which is also maybe some tag in the memory here. So what we can do here, basically, we know that for subtraction, basically how we will do subtraction. If I, for example, this is just general, okay, if I say I want to do A minus B here, so what I can do, I can use an adder to subtract it. Means this will be my 2's complement here. So basically we can say A plus B complement plus 1, which is the 2's complement of B, and then the result can be stored anywhere where you want it. So I will be using the same logic here. Okay, so since we need this 2's complement of the second variable here, so to convert this C, we need to first load this one and then we convert it in the as a 2's complement here. So what we will do here, we can say, for example, LDA load accumulator C here. Simply, I have a certain value of C in the memory. I just loaded it in the accumulator here. Next thing is, now I need to make a complement of it, B complement like this. So I need to make a complement of it. So the command is CMA here. It means that we need to complement the content of an accumulator here. So right now in my accumulator, the value C is there. So I need to just complement it, simple, nothing else. So once we finish with the complement, we need to do this step here. We need to do the addition with 1 here. So what I can do, we can say increment INC here. So INC means basically we are incrementing the content of an accumulator here. So it means that first we loaded C, then we found the complement of it, then we incremented by 1 here. So it means basically we got basically the 2's complement of C right now in our accumulator here. Now it's simple. I have a 2's complement of C in my accumulator. I can add with DIF here. So just simply say add DIF here. So you can add DIF here. Once you add DIF here, you can store accumulator in the memory with the tag DIF here. Okay, simple. Similarly, the last one is basically sum plus, I'm not doing this one, I'm just discussing with you, sum equal to sum plus DIF here. Yeah, only single F. So what you can do, up to you. You can start with sum, you can start with DIF. So load one thing in the accumulator. So that's what I said, load sum in accumulator. Okay. Then I will add with DIF and I will store the value of sum as sum. Or the other way, you load the other variable in the accumulator, add with the other one and store it as a sum here finally. Okay, so you can try this one yourself here. Okay, and now let us start with our last question in this course, which is basically we are going to write a program here. Okay, the question is write a program to multiply two positive numbers by a repeated addition method here. So we are interested in writing a program that can perform the multiplication by the addition method here. Okay, like for example, he gave you the example 5 multiplied by 3. The program evaluates the program product by adding 5 4 times here. Okay, so let's suppose I instead of 5, what I do, I just say that for example I have A, which may be 3, I have B, or let me do it here basically. let me do it here. I said, for example, I have A, which is 3. I have B, which is equal to 2 here. So basically, what I want here, I want like A multiplied by B here. Okay, how you can do it? By repeated addition method. So I can take 3 and add 2 times here. Or I can take 2 and add 3 times here. Both of them will give me the same answer here. Okay, so for that, basically what we are doing, I'm just considering a flow chart here, which I have drawn here, and just let us discuss here how it will do here. First of all, what we are doing here, loading, it can be A and B and 1, okay, but just I give an example that I'm loading A in accumulator here. So by this step, what will happen? My value of accumulator will become 3 here. Okay, next time he said that if this value of accumulator is 0, of course no, so I will follow this route here. But in case the value of accumulator is equal to 0, then what we will do, we will stop here immediately. Means we are multiplying 0 multiply with anything here. So 0 multiplied by anything is 0. So no need to go through all this step here. You can start immediately with the value of accumulator as your answer of multiplication here. So now what we will do here, we are going to find the 2's complement of the accumulator. So it means basically we say the accumulator become minus 3 here. Store as CTR. Okay, this is just a variable I defined. I say this is a counter here. You can say D, E, whatever you want, doesn't matter. Okay, so just any variable here. In this case, he said that the variable is CTR here. So basically, this is like I say that my accumulator is minus 3, and we are also making another variable which is minus 3 here. We clear accumulator, so it means accumulator equal to 0. CTR is minus 3 here, right? Now add B to accumulator. So accumulator is 0. So 0 plus B means 2. So 0 plus 2 will become 2 here. Okay, and CTR is still minus 3 here. Then increment CTR. So CTR will become minus 3 plus 1, which will be equal to minus 2 here. Then the next thing he said that is CTR 0? Of course it is not 0, so I will come back again. I will add B to accumulator here. So my accumulator will become, AC will become 2 plus 2, which will become 4. So my accumulator is 4 now here. And CTR is minus 2 here. Now increment again, so CTR will be equal to minus 2 plus 1 equal to minus 1 here. Is it 0? No, I will go back again. So accumulator will be equal to 4 plus 2 equal to 6. CTR here is minus 1 here. So increment CTR, so CTR will be equal to minus 1 plus 1, which will be equal to 0. So since this is 0, so we can stop here. And the value of accumulator means accumulator equal to 6 will be my answer of multiplication here. Okay, so this is what we are going to follow to write in our program here. Okay, just one thing here, we are going to use two things here, two commands here. Okay, just for your information. Okay, one is basically SZA here. SZA means we need to skip if the accumulator value is 0. For example, what we will have, we have a command like this here, and this is SZA here. So if the value of accumulator, for example, is 0, what will happen? It will skip this line and it will come directly here and execute this whatever we have here. Clear? So skip if accumulator is 0. Skip means skip the next statement or next line and go to the one after it and execute that one. Okay, so basically I will be using this one here to use SZA here. Okay, the second one is which I will be using is ISZ here, which is basically increment and skip if 0 here. Okay, so if I'm not if I'm not putting any variable here, it means I am talking about the accumulator here. So first we will increment the value of accumulator, then we will check if the accumulator is 0 after increment, we will skip. Skip means leave the next line and go to after one, or otherwise don't do anything here, just do as the normal sequence here. Okay, if the condition is not satisfied. If I mention any variable, like I will be mentioning CTR here, So basically, instead of accumulator, now it will be checking the value of CTR here. It will first increment the value of CTR. If the CTR after increment become equal to 0, what will happen? It will skip this line and it will come here directly here. If CTR is not equal to 0, what will happen? A condition is not satisfied, so it will come and execute this one, then it will execute this one, and so on. Okay, so these are the few concepts, few commands which I will be using when writing the program below. Others we already did in the previous question here. So let's start here. What we will do here, first of all, load accumulator. Okay, so what we do here, we say that load accumulator A here. I'm right now here. So I have loaded the value of A in accumulator here. Okay, next thing is accumulator value 0. So what I do here, I told you I'm going to use SZA here. Means it will check the value of accumulator. If accumulator is 0, what will happen? If it is 0, we need to stop it here. So what we can do here, it is going to skip this line and it will come to the next here. And what we will do here, we need to halt our computer here. So if SZA means accumulator value is 0, it will skip it and it will come to the next line, which is halt. Halt means it will stop the program here. Okay. Now in case the value of accumulator is not 0, so it means it should go in sequence here. So what we can do here, we can say branch. I'm just writing NZR here, but not 0 here. It's like some variable here. You can again write A, B, C, D, whatever you like here, but don't repeat the same variable again and again here. Okay, so just write some. So NZR is some tag. You can write whatever you write like it, but I mean it like it's not 0 here. So what will happen? It will jump to NZR here, because if I don't do this thing, it will come to halt here and it will stop here, because they are going in one line in each clock cycle, you can say. So what we will have here, we can go what is NZR here. NZR means first thing is we need to complement here. So we will say that CMA, complement accumulator here. Okay, first thing. But complement accumulator means this is first complement. So I need to increment accumulator also. So these two are basically my two's complement here. Next thing is store as CTR. So what I do, I store accumulator value as CTR, another variable here. Then we say clear accumulator. So we will have CLA here. So basically we did these two here. Now add B to C, AC. So what I can say add B, because in accumulator already I have A here. Then what we will do here, it was A. In accumulator right now it is 0. So 0 plus B will come initially. Okay. Now what we do here, for these two, I told you, like I said that I'm going to use ISZ CTR here. For this one, I use SZA here. So for this variable CTR, what it will do, it will increment the value of CTR first and then check the value of CTR. If CTR is 0, then what it will do, I should branch some tag here. Okay, this I write loop here. So if the value of CTR after the increment becomes 0, it means I need to stop it. So it means what you can do, it will skip this line and come to the next one. So it will halt the computer here. Or if the condition is not satisfied, so it should go back and add here, like this line here. So what we can say that it will be loop again here. Okay. Now quickly, just let me tell you again, load A in AC. So I have loaded A in AC here. Okay, then accumulator equal to 0. So it's checking here. If it is 0, then what it will do, it will come to halt, means it will skip this line here. If this is not 0, what will happen? It will come to branch here. Branch means jump. So what it will do, from here, it will jump to this location here. It will not come to this line because I'm jumping to another location. So branch and that so it will not come to halt at this point here. Then what it will do, it will complement and increment. So means this is my two's complement together. this one. Then store CTR, the accumulator of value is stored as CTR. Then we clear the accumulator here. Okay, now we added B. Then what we do for this two, what we do, we just increment the CTR and we check if the value of CTR after increment is 0. If it is 0, what will do? It will come here directly. It will skip this line here, so it means it will stop the program here. But for example, if it is not equal to 0, what it will do? I say that jump to CTR here. So it means from here, it will jump again to this position here. Because this is loop here, so this is loop here, so it will jump to this tag here. So this is what we are doing here. Okay, and then it is going to add and continue when it becomes stop. When it becomes, for example, equal to 0 CTR, what will happen? It will skip this line and it will come to halt directly here and it will stop the program here. Clear? So this was all about the program here. But since this is a program here, so what you can see, you can start from here. You can say originate here with certain address here. So you can specify that, okay, my program will be loaded in the memory or stored in the memory in this location here. Start from this location, 100 or maybe in hexadecimal something here. Also, what we can do here, I can variable, after finishing this one, we can define your program here. We can say A is maybe some decimal number here, some number, okay, I have not defined here. B is again some decimal number here. Similarly, we use CTR here, which is, let's suppose, hexadecimal number, or even you can write the decimal number here, okay, and then you can end your program here. So what you do here, basically you originate your program here and you end it here. This is your variable declaration here, okay, and this is what we have. One more thing just before leaving here, let me make it small here so it's okay. Remember, okay, these two, in fact, this one CT, sorry, not this one, this NZR, this is a tag here, okay. You can say branch D and then you need to write D here, okay, like it's something you are defining yourself. We say that jump to this location here. Similarly, branch loop, you can say, for example, F here and you can write F here also, okay. So whatever you specify, just write the same tag value here, okay. This is variable up to you. Again, this is another variable up to you. You can write any variable name here, you can give it, okay. Even I think A and B you can specify yourself by specifying different variable. But please don't say A equal to 5 and instead of B you are again writing A equal to 6. Then it is confusion and I think the value of A will be only 6 here. Okay, so just try to use different variables for different things here. So this was all about our course here. Just before leaving, one more comment here, just one more please. You may be thinking that I'm writing a comments here or I'm writing the commands here, from where it is coming. So this is some computer instruction already provided to you in your core textbook. This is taken from the textbook and it's also given to you in the sheet here. Okay, so what I have done here, like I have done add here, load accumulator, store accumulator. Description is here, what it means this here. Branch, what the branch is doing, what is ISZ doing here, what is clear accumulator doing here, everything is here, okay. Also we use halt here. Where is halt? This is halt here. There is another one SZA, skip if accumulator is 0. Okay, so this is like all the instruction set from which I have written the program here. Okay, so please just refer to it. All the description is provided here. Read it, and if you have any doubt, you can discuss with me. Okay, so this was all about today's tutorial, and this is in fact your last tutorial. And wish you all the very best for your exams here. Regarding the quizzes, most probably I may give you an extra quiz, okay, as per the demand of you. Basically I was not planning here, but I get a lot of requests from the different students to give you an extra quiz, so I will give you an extra quiz. And obviously again same rule, I'm going to count the best. If it is I give you extra quiz, it means it will become 4 quizzes, then I will take best 3 quizzes here. Simple. Okay, so have a nice time, brothers, and wish you all the very best. Assalamu alaikum.